Hi there, in this video we are tackling LeetCode problem number 125, a valid palindrome. It is an easy level problem, but it is absolutely essential for coding interviews and builds foundational skills. This problem teaches you about string manipulation, character validation, and the powerful two-pointer technique. These concepts appear everywhere from data validation in web applications to text processing algorithms, and even in more advanced problems involving arrays and linked lists. So let's dive in and see what needs to be done. Let's begin by understanding the problem statement. A string or phrase is considered a palindrome if, after converting all uppercase letters to lowercase and removing all non-alphanumeric characters, it reads the same both forward and backward. Here, alphanumeric characters refers to letters and numbers. So, given a string S, our task is to return true if it is a palindrome and false otherwise. The key insight here is that we need to pre-process the string first. We cannot just check the original string as is. We need to normalize it by removing spaces, punctuations, and making everything lowercase before we can determine if it is a palindrome. Now let's quickly go over the constraints. The string length can range from 1 to 2 times 10 to the power 5 characters, which means up to 200,000 characters. The string consists only of printable ASCII characters. These constraints tell us that we need an efficient solution since we could be dealing with very long strings. The fact that we are limited to printable ASCII characters simplifies our character validation logic. So with those constraints in mind, let's walk through our first example to see how pre-processing works. We are given the string S equals a man starting with an uppercase A, followed by a comma and space, a plan, then a comma and space, a canal, then a colon and space, and Panama with an uppercase P. The expected output is true. Now here is the reasoning. Before checking if it is a palindrome, we follow these steps. First, we convert all uppercase letters to lowercase. Next, we remove all non-alphanumeric characters. This means removing spaces, commas, colons, and many other punctuations. After this step, the string becomes this. Finally, we check whether this processed string is a palindrome. Looking at it, we can see that it reads the same forward and backward. To make it clearer, we can even highlight matching characters with the same colors. Since the string is identical in both directions, it is indeed a palindrome, and therefore we return true. Now let's look at our second example to understand what makes a string invalid. We have S equals the word race, followed by a space, then the character A, followed by another space, then the word car, all in lowercase, and the expected output is false. Let's trace through the pre-processing steps. First, we convert the string to lowercase. In this case, there are no uppercase letters, so the string remains the same. Next, we remove all non-alphanumeric characters. So after removing the spaces, the string becomes this. Finally, we check whether race a car is a palindrome by comparing it forward and backward. Most of the characters match when highlighted with the same colors, except for the characters E and A in the middle. They do not have a matching counterpart. Since not all characters align, the string is not a palindrome. Therefore, we return false. Now, our third example shows an edge case, where S equals an empty string and the output is true. The explanation is that after removing non-alphanumeric characters, we get an empty string. Since an empty string reads the same forward and backward, it is considered a palindrome. This is an important edge case to remember. Empty strings are valid palindromes by definition. So now that we understand the problem, let's explore the solution approaches. The first is the reverse and compare approach. which creates a reversed copy of the cleaned string. That is, the string after converting all letters to lowercase and removing non-alphanumeric characters. The second is the two-pointer approach, which avoids creating an extra copy and is therefore more memory efficient. Let's start with the reverse and compare approach. Here, the idea is simple. We first clean the input string, then create a reversed version of it, and finally check whether the two are the same. Let's visualize this with an example. Suppose we have the string S equals the word race followed by a space, then the word car. After pre-processing, that is removing spaces and converting everything to lowercase, we get the cleaned string, race car. This is now ready for palindrome checking. The next step is to reverse the cleaned string. Reversing race car gives us race car again. Interestingly, it looks exactly the same. Finally, we compare the original cleaned string with the reversed one. Since the characters in the race car and race car are identical, we can conclude that the original string is indeed a palindrome, so we return true. However, if they don't match, like in our earlier example with S equals race a car, then we return false. Simple, right? For the code implementation of this solution, we begin by defining the method signature. The method is called isPalindrome, which takes a string S as input and returns a boolean indicating whether it is a valid palindrome. First, we clean the string by removing all non-alphanumeric characters and converting it to lowercase. We use the replace all method with this regular expression to strip out unwanted characters. Then call the toLowerCase method to normalize the case. This way, we only compare letters and numbers, ignoring spaces, punctuation, and case differences. Next, we create the reversed string using string builder. By calling the reverse method and converting it back to a string, we efficiently get the reversed version of our cleaned string. Finally, we compare the cleaned string with the reversed one using the equals method. If they match, the original string is a palindrome and we return true. Otherwise, we return false. As for the time complexity, this approach runs in big O of n time, where n is the length of the string. Each character is processed once during cleaning, once during reversal, and once during comparison. The space complexity is big O of n as well, since we create additional strings, the cleaned string and the reversed string. So, while the reverse and compare method works, it is not the most memory-efficient approach since it creates extra strings. The two-pointer approach is better. It places pointers at opposite ends and moves them inward, checking characters along the way. This works because in a palindrome, the first character matches the last, the second matches the second to last, and so on. You already saw this symmetry when we highlighted matching characters with colors on screen. Here, we apply the same idea directly without creating a reversed copy. Let's visualize this process using this example string. This is the cleaned up version of the original string. Was it a car or a cat I saw? Where we have removed spaces, punctuation, and converted everything to lowercase. Since it is already cleaned, we can go ahead and apply the two-pointer technique directly to check if it is a palindrome. We start with 2 pointers on the string, one at the very beginning called left and one at the very end called right. First, we compare the characters at these positions. At left equals 0, we have W, and at right equals 18, we also have W. They match, so we move the pointers inward. Now, at left equals 1 and right equals 17, A matches A. Next, at left equals 2 and right equals 16, S matches S. So we keep going. I with I, T with T, A with A, C with C, A with A, and finally R with R. Since every pair matches as the pointers meet in the middle, we can confidently say this string is a palindrome, so we return true. Now, before we jump into the code, there is an important observation to note. Look at the character in the center at index 9. Since this string has an odd length of 19, this middle character does not have a pair, and there is no need to check it. Odd length palindromes always have a single center character. However, if, let's say, you have an even length palindrome of length 20, in that case, you would have to check the middle characters also. If it is matching, which is the case here with 2 O's, then it is a palindrome. However, if the character at left does not match with the character at right, then it is not a palindrome and you would return false. For the code implementation of this solution, we begin by defining the same method signature as before. First, we handle edge cases. If the input string is null or empty, we return true. Next, we initialize 2 pointers. The left pointer starts at index 0, pointing to the beginning of the string, and the right pointer starts at s.length -1, pointing to the end of the string. We then start a main comparison loop with the condition left less than right. This ensures we keep processing until the pointers meet in the middle or cross each other. Inside the loop, we first skip any non-alphanumeric characters from the left side. We use a while loop that continues as long as left is less than right and the character at the left pointer is not a letter or digit. The character dot is letter or digit method efficiently checks this. For each non-alphanumeric character, we increment the left pointer until we find an alphanumeric character or until the pointers meet. Similarly, we skip non-alphanumeric characters from the right side using another while loop, decrementing the right pointer for each non-alphanumeric character we encounter. Once both pointers are positioned at alphanumeric characters, we perform the comparison. We use character.toLowerCase method to convert both characters to lowercase before comparing them, which handles the case-insensitive requirement of the problem. If the characters don't match, we immediately know the string is not a palindrome and we return false, as there is no need to check the rest of the string. However, if the characters do match, we move both pointers towards the center, incrementing left and decrementing right, and continue checking the next pair of characters. Finally, after the loop completes without finding any mismatches, we know that all alphanumeric character pairs matched correctly. This means the string is a valid palindrome, so we return true. Now, you might be wondering, why do we skip non-alphanumeric characters at the left and right pointers instead of simply removing them like how we did in our previous approach using regular expressions or other alternatives? This is actually a clever technique because removing characters would take big O of n time complexity and extra space, while this 2-pointer approach is space efficient and works in big O of 1 extra space. Let's see an example so it is clear, so you won't proceed feeling disappointed or confused in the next lecture. Suppose we have this string, and we want to check if it is a palindrome. So we start by placing 2 pointers, left at index 0 and right at index 8. Comparing the characters at left and right in a case-insensitive manner, we see that they match. So we move the pointers inward by incrementing left and decrementing right. Now, the character at left is a non-alphanumeric character, so we skip it. Similarly, the character at right is also non-alphanumeric, so we skip that one as well. Skipping these characters avoids unnecessary operations and keeps the logic clean. We then compare the next pair of characters at left equals 2 and right equals 6. They match again, so we continue moving the pointers inward. We skip the pound character at left and the dollar character at right. Finally, When we compare the last character E at indices 4 and 4, they match perfectly. Since all the alphanumeric characters match correctly, this strange-looking string is indeed a palindrome. As for the time complexity, this approach runs in big O of n time, where n is the length of the string. Each character is processed at most once during the comparison phase. The space complexity is big O of 1 because we only use a constant amount of extra space for the 2 pointers regardless of the input size. So, to summarize, we learned how to check if a string is a palindrome by either first cleaning it and using the reverse and compare method, or by using the more efficient 2-pointer approach. We also covered edge cases and highlighted the key insight that we only need to compare characters while the pointers have not crossed. And with that, let's wrap up this lecture here, and I will see you in the next one.